Across the immeasurable canvas of the universe, the light of stars spills outward like ancient stories written in photons. Every world that orbits them, every frozen moon, molten sphere, ocean planet, and storm-wreathed giant, sees its star differently. Even our own sun, familiar and constant from Earth, becomes something strange, alien, and unrecognizable when viewed from distant exoplanets. This is the story of how our sun would appear if you stood on worlds that orbit other stars. It is a journey through impossible horizons, skies tinted with colors no human eye has ever witnessed, and the raw physics that shape these visions. The universe is full of eyes, planets, moons, clouds, oceans, and each one sees our star in its own way. Imagine standing on Earth, knowing the sun as a blinding white sphere suspended in soft blue, warming everything around you. Now erase that sky. Replace it with atmospheres of methane, hydrogen, nitrogen, neon, or nothing at all. Replace the Earth's mild orbit with the frozen darkness of distant outer systems, or the infernal heat of ultra-close planets. Replace the comfortable 150 million kilometers with distances so enormous, the sun becomes just another dim point in the night. This is the perspective of the cosmos, your sun as an alien star. If you could teleport from one exoplanet to another, watching how the sun transforms each time, the first thing you would notice is this. Distance changes everything. Light weakens with the square of distance. Every doubling dims the sun by a factor of 4. At 100 times Earth's distance, the sun becomes a pale ember. At 1,000 times, it resembles nothing more than a lonely star lost in the void. At 1,000,000 times, it would disappear entirely from human sight, swallowed by cosmic darkness. But atmospheres also sculpt the sun, bending light, filtering it, transforming it into colors Earth can never produce. Some skies scatter blue like ours. Others extinguish blue entirely, leaving only red. Others have no atmosphere at all, letting sunlight burn sharp and painful. Some distort the sun into elongated ovals, shimmering like molten metal. Some worlds see the sun rise as a blood-red smear. Others see it dissolve like a spark in fog. Each world creates its own version of our star. Now imagine the journey begins. You awaken on Mercury-like exoplanet, scorched and trembling from the proximity to its parent star. But far above yourself, the sun is not the sun. You're not in the solar system, and Earth is only a memory. Still, you imagine how the sun would look from here if this were your home. It would fill nearly half the sky, a golden titan with flames whipping off its edges, arcs of plasma towering thousands of kilometers high. The heat would feel like standing beside a furnace the size of a continent. Observing the sun from such a world would be impossible without protective shielding. Sunlight would burn your vision in fractions of a second. From such a vantage, the sun would be a monstrous deity, unstoppable, unbearable, yet mesmerizing. But that is only one extreme. Now imagine yourself teleported billions of kilometers outward to the edge of a distant Kuiper belt analog. Here, the sun is barely brighter than the full moon. It casts long, ghostly shadows with blurry edges because your eyes struggle to distinguish the sun from the surrounding darkness. Its warmth is gone. You could stare straight at it without pain. It is no longer overwhelming. It is lonely. It hangs in a black sky as a tiny white speck, insignificant compared to the cosmic ocean surrounding it. If you continued outward into interstellar space, the sun would shrink further, fading from white to pale gold, then to a faint, trembling spark. Only instruments would be able to tell you that this is your star. To your eyes, it becomes just another point of light among billions. But that is still not the end of the journey. Now the real adventure begins, standing on exoplanets, worlds orbiting stars light years away, seeing our sun through alien skies. Your first stop is Proxima b, orbiting the nearest star beyond the sun. The sky is suffused with infrared radiation invisible to your eyes. The landscape is dim, as though eternally trapped in twilight. The star Proxima Centauri looms as a dull red ember, flickering occasionally with violent flares that bathe the horizon in bursts of ultraviolet light. But you are not here to see Proxima. You look upward, searching. There, barely visible, sparkles a pale, steady star. That is your sun. From Proxima b, the sun would look no brighter than the brightest stars in Earth's sky. You could cover it with a grain of sand held at arm's length. It is so distant, so faint, it would blend seamlessly into the cosmic tapestry unless you knew exactly where to look. And yet, that tiny glimmer holds everything. Earth, the moon, Jupiter, humanity, our oceans, our entire history, compressed into a single, trembling speck of light. From this vantage point, the universe feels enormous and indifferent. The sun is only one among countless stars. Earth's immensity collapses into an invisible atom-sized dot. You become aware of a new reality. If someone lived here, they would not know Earth existed. To them, the sun would be anonymous, one star out of trillions. But now move on to a super-Earth orbiting a brilliant blue-white star like Vega. Here the sky is saturated with light. Shadows look unnaturally sharp. Colors appear slightly washed, as though overexposed. The star Vega burns so intensely it dominates everything. But you are looking for the sun, and you will not find it with the naked eye. The sun from Vega's worlds would be one of the dimmer stars in the night sky, flickering faintly like a cold grain of sand. You could search for days and still overlook it. The sun would not be special. Nothing in its appearance would hint that it nurtured life on a distant blue planet. Next, you stand on Kepler-186f, bathed in the soft red-orange glow of a cooler K-type star. Its light is warm, calming, reminiscent of Earth's sunsets, but permanent. Here the sun is completely lost among the stars. It is too faint even to distinguish without calculations. To the inhabitants of this world, if any exist, the sun would not matter at all. It would be invisible to culture, mythology, and science, until they invented telescopes capable of mapping the faintest points of light. The thought feels unsettling. The sun, which dominates Earth's existence, becomes meaningless elsewhere. Now travel farther, to a world orbiting a red giant. This is one of the most dramatic vantage points you will ever encounter. The star in the sky is swollen, distorted by convection, its surface boiling and shifting like a living, breathing cosmic flame. The planet's atmosphere filters the crimson light, flooding the horizon with colors ranging from deep scarlet to shimmering orange. If you searched for the sun, you might find it, but only as a microscopic point lost in the overwhelming shine. This sky feels heavy, ancient, and apocalyptic. Worlds like this do not last long. Red giants are dying stars. From such a place, the sun is nothing more than a memory of a distant, younger universe. You go farther still, to planets orbiting pulsars. These star remnants emit beams of radiation like interstellar lighthouses. Standing on a rocky world near a pulsar would be surreal. The sky flashes rhythmically, bathing the landscape in ghostly pulses of blue light. Here, the sun is invisible. Not figuratively, literally. It emits too little energy compared to the pulsar's deadly brilliance. Even with powerful telescopes, the sun would be a faint background star, drowned by the pulsar's blinding tempo. Now leap to the most exotic vantage point, a planet orbiting a black hole illuminated by distant starlight. This is not fantasy. Scientists have theorized stable orbits around black holes. The sky above you is distorted by extreme gravity. Light from distant stars curves around you, forming arcs and rings. If you search for the sun, you might see it, but not where you expect. The sun's image, warped by gravitational lensing, may appear in several places at once. You could watch the sun rise on one side of the horizon and see its ghost, an image bent by gravity, glimmering elsewhere. Here, the cosmos folds in on itself, and the sun becomes a distorted echo of its former self. On some worlds, the sun appears red, on others, blue, on others, yellow or white. On some, it flickers like a soft ember. On others, it resembles a cold pinprick. On a few, the sun is entirely invisible. The diversity of cosmic vantage points reveals a profound truth. Stars are not absolute. They are relative. A star's identity, its color, brightness, temperature, personality, depends on where you stand. From some planets, our sun would appear powerful and overwhelming. From others, it would be utterly insignificant. And from many, it would not exist at all, swallowed by vast distances. As you continue this journey, you begin to realize that perspective shapes meaning. Humans often assume the sun is extraordinary because it is ours. But in the universe, it is ordinary, very ordinary. A yellow G-type dwarf of no special distinction. Many stars are larger, many are brighter, many are hotter, cooler, older, younger. Only from Earth does the sun command such reverence. And yet, this is the part the universe does not tell you. The sun is unique in one way. It is unique to us. It is the only star whose warmth we feel on our skin, whose gravity cradled us into existence, whose light raised forests, oceans, and millions of species. It is the only star that humans have ever seen up close. From our perspective, the sun is not merely one among billions. It is the parent light that shaped our history. Standing on an exoplanet, watching the sun as a tiny speck, you feel an unexpected emotion, homesickness. That faint glimmer thousands of trillions of miles away is home. It is your warmth, your oceans, your mountains, your civilizations, your origin. Then comes the deepest realization of all. Every star is someone else's sun. Somewhere out there, on a world we have never seen, intelligent beings may look up at their star and believe it is the center of everything. They may consider it the brightest, most important light in the universe. They may never know yours exists. The universe is too vast for a single perspective to hold dominance. Every world has its own sky. Every sky has its own truth. So what does the sun look like from exoplanets? It looks ordinary, it looks faint, it looks forgettable. Yet when you understand why, you begin to see the cosmos with new eyes. You understand that significance is not in the brightness of a star, but in the life that surrounds it. From a trillion worlds, the sun appears as a meaningless dot. But from Earth, it is everything. As you drift across the galaxy, each exoplanet's sky reshapes the sun's identity. The cosmos whispers the same lesson again and again. Perspective defines reality. From one world, the sun is a god of fire. From another, it is a cold mote of dust. From another, it is invisible. And from one, Earth, it is the torch of life. Your journey ends where it began. Looking at the sun from home, the sky is blue, the air is warm, the sun is bright. And suddenly, after crossing countless alien horizons, you feel grateful. Because from here, from this singular world, the sun is not just a star. It is the beginning of everything you know.